Today, we are diving deep into what might just be the most complex object in the entire known universe. Yeah, the human brain. We're going to explore how it can be influenced, how it speaks its own unique chemical language, and, get this, how new tech is finally helping us decode its deepest secrets. Just think about that for a second. Every single thought, every feeling, every memory you have, it's all a massive flurry of activity inside your head. It is a constant, impossibly complex conversation. And for, well, all of human history, that conversation was totally locked away. But what if we're right on the verge of a breakthrough? What if we could finally tune in?
So, first things first, let's just get a fundamental point out on the table. Your brain isn't some magical box of consciousness floating around in your skull. Nope. It's a physical organ. And just like any other organ in your body, it can be physically affected by outside forces, sometimes in ways we can't even see.
Okay, it is so important to make a distinction right here. Look, we're all surrounded by low-level microwaves all the time, from our phones, from Wi-Fi, and that stuff is generally considered safe. But that is not what we're talking about. We're talking about something else entirely. High-power, pulsed microwaves. This is the kind of stuff you'd find in military or really advanced research settings. And their effect on the brain? Well, that can be pretty significant. So you might be wondering, how does this even work? Well, research points to three main ways this can happen. First, you've got the obvious one, thermal effects. High-power microwaves can literally heat up brain tissue, but it gets a lot more subtle than that. There are also non-thermal effects. You know, think of it less like a microwave oven and more like a super powerful radio signal interfering with a broadcast. The energy itself can disrupt what the neurons are doing. And then there's this third thing. When these waves are pulsed, they can create tiny little acoustic waves inside your skull, which actually makes those non-thermal effects even stronger. And the potential consequences of this are pretty serious. Studies have shown these high-power microwaves can actually alter brainwave patterns. They can mess with the release of crucial chemical messengers and even impact things like memory. Some of the research even suggests they can make the blood-brain barrier, which is this super important shield, more permeable, maybe letting harmful stuff in. So the big takeaway here is clear. The brain can absolutely be physically influenced from the outside.
All right, so we've established that the brain can be influenced from the outside, but if we want to truly understand how to decode it, we first have to learn its native language. I mean, how does it talk to itself? How does it talk to the rest of your body? And that language, believe it or not, is all about chemistry. This field is called neurochemistry, and it's basically the science that investigates all the chemical bits and pieces and the processes that make our nervous system work. It is literally the science of how your brain speaks. So the brain has this amazing toolkit to get the job done. You've got neurons, which are like the biological wiring, just relaying messages all over the place. Then you have neurotransmitters. These are the actual chemical messages, kind of like tiny, specific little notes being passed between the neurons. Hormones play a bigger, broader role, regulating functions across the whole body. And all the magic really happens at the synapse, this tiny, tiny gap between neurons where these incredible chemical conversations take place. And if you put it all together, the process kind of looks like this. Your brain, our central computer, sends an electrical impulse zipping down a neuron. When that impulse gets to the very end, that electrical signal triggers the release of those chemical neurotransmitters across the synapse. Then the next neuron in line picks up that chemical signal and, boom, the message continues on its way. It's this incredibly fast and ridiculously complex electrochemical dance. Okay, and now we get to the really wild part, the breakthrough. We know the brain can be influenced, and we get its basic chemical language. But how in the world do we translate that language in real time? Well, the answer, more and more, is artificial intelligence. The big problem we've always had is just the sheer amount of information. I mean, the brain is firing off billions of signals at any given moment. It's an absolute torrent of unbelievably complex data, way, way too much for any single person, or even a huge team of people to analyze on their own. And this is where AI completely changes the game. See, machine learning and deep learning models can sift through all that noise. You can actually train them to spot the meaningful, super subtle patterns in brain activity that line up with specific thoughts or intentions or mental states. So how do we even get our hands on this data? Well, for the most part, we use a tool called an EEG. By putting sensors on the scalp, we can listen in on the brain's electrical chatter without any surgery. It's totally non-invasive. The EEG gives us the raw brainwaves. That's the language that our AI translator needs to get to work.
And let me tell you, AI absolutely supercharges what we can do with this EEG data. We're already seeing AI models that can interpret these scans with the same accuracy as a human expert. Generative AI can even create visualizations in real time of what someone is feeling, like anxiety or calm. And it does all of this with a speed and an efficiency that's, well, it's just not humanly possible. So this combination, this partnership between EEG and AI is taking us to a place that, honestly, until just a few years ago, was pure science fiction. We are getting closer and closer to actually reconstructing the contents of a thought. Just really let that sink in for a minute. If you're looking at a picture, or maybe even just imagining one in your mind's eye, could an AI tap into your brain and see it too? You know, it actually goes beyond just images. Researchers are working like crazy to develop AI that can decode what they call inner speech. Yep, that's the silent monologue that's probably running in your head right now. By analyzing all this complex EEG data, AI is learning to pick out the specific brain patterns that go with the words you're thinking. The real trick, though, isn't just hearing words, it's trying to separate that one intended signal from the constant noise of all our other random fleeting thoughts. So, back to the big question, can an AI see what you see? And the answer is, yeah, kinda. Researchers are using AI to analyze brain activity from both fMRI and EEG scans to basically reconstruct what a person is looking at or even just what they're imagining. Now, the results aren't perfect, not yet, but they can be seriously, strikingly similar. It's mind-blowing stuff. And all of this brings us to the new frontier. This technology is incredibly powerful. It holds the potential for both unbelievable promise and some pretty significant peril. We have to be so careful about how we balance them. I mean, on the one hand, the applications are completely life-changing. We're talking about AI that can predict epileptic seizures, giving people time to get safe. It's powering technology that lets people control prosthetic limbs with just their minds. It's helping people who've lost their ability to speak to communicate with their loved ones again. The medical potential is it's astounding. But of course, with this kind of power, you get some really big questions. You have to. It's not just about making the tech work, it's about making it work for people, safely and ethically. For instance, who owns the data from your brain? How do you keep it private? And as these AIs get more and more complex, how do we make sure we can even understand how they're making decisions? These aren't just little details to figure out later, they're central to this whole thing. And that kind of leads us to our final question for today. As this technology moves out of the research lab and into our actual lives, we are going to face some incredibly profound questions. When an AI interprets a brainwave, is that really a thought? And who gets to make that call? The line between our technology and our own consciousness is getting blurrier by the day, and you and I, we are the generation that's going to have to figure out how to navigate this brave new world.